Okay, we will today continue with the studies on short circuit of salient pole synchronous machines. We have taken a comprehensive model. One is a salient pole model, okay. Then it has damper windings, right, and we assume that before short circuit it is an open circuit, okay. Then a 3-phase dead short circuit occurs at the terminals of the generator, okay. Then how do you find the response using our dynamic model, okay? And we assume that the synchronous speed is not affected, so we do not take care of mechanical equations, right, speed is remaining constant. Now, we also have to understand what happens before short circuit and what happens immediately after short circuit, okay. Now, before short circuit all the currents IA, IB, IC are 0, which means ID, IQ are 0, but before short circuit there is a voltage across the field, Vf is there, Vf is constant and If is constant, okay. This is the condition. What will happen after the short circuit? Immediately after short circuit, your VA, VB, VC becomes 0, and so VD, VQ becomes 0, right. And before short circuit VD, VQ, VD was 0 before short circuit, and when IA, IB, IC is 0, VD is what? VD is nothing but omega lambda q, and lambda q is in q axis it is only LQ, IQ. Therefore, VD is 0 before short circuit and after short circuit. So, there is no change in VD, but what happens to VQ? VQ was omega LAF IF before short circuit, and then after short circuit it becomes 0, okay. Therefore, the effect of short circuit is to apply a minus VQ in the Q axis, minus omega LAF IF on the Q axis, that is what it means. So, our objective is to see what is the impact of adding this additional voltage. So, if we find the response of this system, this set we call the set 3, then our problem is solved, because that will be whatever was the set 1 plus set 3 will become our net result. So, we assume that whatever before short circuits it continues, and we are only trying to see what changes will be there, okay. So, we have found out the before and after, and will there be any change in Vf? No change, because you are applying the same voltage, but there will be change in If. Earlier If was constant, then If may also undergo a change, right. So, the ID will undergo a change, IQ will undergo a change, If will undergo a change, okay. Our concern is to see how to estimate or get some relevant formulae or equations of these currents, okay, after this. So, we did this as a last one quickly as case 1. What we did was we took all the resistance to be 0, right, as the first case. So, all the resistance will be 0 means VD is 0 is equal to, we got this expression, and VQ was nothing but minus VQ, we are applying this, because VD we are not applying anything because it is 0, minus VQ is, we know that is minus omega LAF IF, okay. So, that you apply minus VQ, then that will be P lambda Q plus omega lambda D, and Vf was 0 because there is no change, because this is for the set 3, right. So, you are not applying anything for Vf. So, Vf is 0, which is P lambda F. So, Vf was 0 means lambda F is constant, but lambda constant, but lambda F is 0. because there is no change in anything. So, we find that under this condition lambda f is 0, no change in the flux linkage of the field. Okay. So, we get what the constant flux linkage theorem, that means flux linkage in a closed circuit with 0 resistance and with no voltage source will be constant. This is a constant flux linkage theorem, right. If you do not have a closed, so it is almost like a Lenz's law. So, flux will not change and this will be the objective. Now, we said that flux linkage, supposing lambda d, in the d axis what will happen is where lambda d, okay, this is lambda f and this is lambda k d, is not it. This is d, the d axis are 3 windings, d winding, f winding and k d winding, is not it, right. We find that this lambda f is 0, but there will be a lambda d, okay, and lambda k d is 0. So, we have 3 equations and 3 unknowns, is not it. So, we can write I d in terms of lambda d by a Kramer's rule. 3 equations, 3 unknowns, they are all algebraic equations. Is it okay? In the d axis we have algebraic equations with all the known parameters of inductances, okay, and we write this I d as a determinant over delta. So, lambda d 0 0 etcetera, and then delta is, actually there is a mistake here. The delta is the coefficients of all this. So, d coefficient is root 3 by 2 MAF, I think it should have written. It is not P lambda f, MAF. So, I had asked you to verify this, okay. So, I d will be lambda d LF LKD minus MF KD square by delta. So, lambda d will be some constant into I d, right, and we write that constant as LD double dash, and that LD double dash is a function of the existing parameters or inductance parameter. Okay. So, LD double dash we call it as subtransient d axis synchronous reactance, it is a subtransient. At immediately after short circuit this will be the inductance, because at this the lambda d at that instant will be LD double dash into ID flux linkage, because for that it will be like there are 3 windings, one winding is only having a flux linkage, other windings are all short circuited, okay. Lambda f is 0, lambda k d is 0. So, this will be the term, and on simplification we have LD double dash will be LD minus this quantity. So, LD minus certain quantity means it will be much less than LD, and we said, so the subtransient reactance will be very small compared to the normal steady state reactance LD, okay, d axis reactance. Now, same thing you can do along q axis. So, q axis what you have? You have the q winding and kq winding, there is no f winding another q axis, right, and there will be a lambda q here and lambda k d is 0, okay, and that is, and you know lambda q is LQIQ plus this, there is only a linkage of these two, right, and lambda KQ. So, this you can write it as LQ double dash into IQ, because you have a, you can find out L, just a simplification. So, LQ double dash is lambda q by IQ. So, LQ double dash is LQ minus 3 by 2 MAQ square this. So, it will also be less than LQ. So, you have a new reactance coming immediately after a short circuit, okay, wherein it will be the effective reactance. You can always say it is like a reactance with transformer with secondary is short circuited. So, looking from the primary side, you will have a net reactance, is not it? Okay. In fact, you can also read, I suggest you also read Adkins' generalized theory of machines. He has also dealt with it quite nicely, I must say, quite nicely. Because these are the things, whether you are in the working on the machines or power system, you need to know. Okay? Because this will decide the power system dynamics, okay, with the machine connected to an infinite bus, and how it has to be analyzed under various disturbed or transient conditions. Okay, is it clear now what is meant by subtransient reactance under the D and Q axis? So, we will have lambda q and immediate will be LQ double dash into IQ, right. So, you have to find out what is an ID and IQ for these conditions. Okay. Now, we know the voltage equation will be V d is 0 is equal to P lambda d minus omega lambda q, V q is minus V q, this is fixed, you are applying a minus DC, right, you are applying minus V q, right, omega lam LAF IF, okay, and then you want to know what is the impact of this minus V q on this. So, P lambda q plus omega lambda. But whereas lambda d we have defined this lambda, lambda d lambda q you have defined, right. Okay. So, you can say this is nothing but what omega L d double dash I d minus P L d double dash I d minus omega L q double dash I q, is not it, and this will be P L q double dash I q plus omega L d double dash I d, right, and of course, this will be P lambda f, right. Now, which is 0, we found LF is constant. Now, these two equations take Laplace transform, right. So, Laplace transform you put P, replace P with S, is not it. So, it will be 0 is equal to S times lambda d, because omega lambda q minus V q, that is a fixed DC. So, Laplace transform of fixed quantity is V q by S, is not it, right, minus V q by omega lambda d S lambda q. Okay. I hope you are clear up till now. So, we have two equations, two differential equations, linear and with fixed quantities. Okay. Now, this is you have to solve the Laplace equation. So, you have a lambda d lambda q, okay, as a function of S, agreed, just solving. So, you have to verify this. I mean, that is not a big deal, because you have to, these are the what these are the unknowns are lambda d lambda q's, right, and all others are known. So, you can find out lambda d lambda q. When once you have lambda d lambda q in terms of Laplace transform, I hope all of you are aware of Laplace transforms, okay, right. So, its inverse Laplace transform will give you this lambda t, is not it. When you have lambda d s is this and lambda t will be inverse of this, is not it. Laplace transform inverse of this term. And similarly, sorry, now ID t will be lambda d by LD double dash, isn't it? So, this if you this Laplace transform will become VQ by omega at 1 minus cos omega t, the inverse. Similarly, lambda q t will be this minus VQ by omega sin omega t. So, what we get is an IQ t, IQ as a function of time immediately after short circuit, if you neglect all resistance, will be minus VQ sin omega t by xq double dash. Okay. Right. Of course, minus means that because current is going out, because we have taken the motoring conventions, so that is why we get the minus, right. So, if we so what do we have? We have ID is minus VQ by XT double dash into 1 minus cos omega t, isn't it? I hope that is the I think that sorry, this omega should not be there. Okay. Is it okay? We have a term, simple term VQ by XT double dash 1 minus cos omega t, and IQ is minus VQ by XQ double dash into sin omega t, isn't it? So, what does it so if you plot IQ versus omega t, how will this be? So, we can say it is some minus some constant k1 into 1 minus cos omega t, isn't it? This will be minus some constant k2 into sin omega t. Okay. So, this will be minus k1 plus k1 cos omega t. Okay. So, what is 1 minus cos omega t? It will be minus, no? Okay. Let me try to plot. Supposing this minus k1, then plus k1 cos omega t. So, if omega t is 0, this will be now if omega t is 0, this is 1, no? Huh? No, omega t is 0, this is 1, isn't it? No, omega t is 0 means this is 1. Huh?
Minus k1 plus k1 is equal to 0 total.
That is what I am saying. So, it will start here. Okay. So, we may have a I don't know, something like this. Am I right? Huh? Yes or no?
Yes, sir.
Huh? So, you have this term ID will be something like this. What will be IQ? Sorry, this is ID, no? IQ will be, whereas this I considered to be minus K1. Okay. What will be this? This will be minus K2 sin omega t. So, it will minus sin omega t. So, it will be so this will be minus K2, right. So, what that means if you neglect resistance it will be become a sinusoidal, dq quantities will be sinusoidal with time, but which has a this is a DC component. So, we conclude that ID will have a DC component plus DC plus what? Not transient, DC plus a AC of omega frequency. So, this is a sinusoidal component, and IQ also will have, it has no DC. So, it is only AC of omega. So, this will be a cos component, this will be a sin component. They are shifted by IDIQ are shifted. So, it will be fundamental plus sorry, the DC plus fundamental. I want you to appreciate this because these are little concepts you need to assimilate at this point in time, right. So, if you neglect all the things immediately after short circuit, it will have ID and IQ will be having a DC plus sin square component. Okay. Now, you will go back, what happens under normal steady state operation? So, this is under transient, but steady state? Steady state what DC will not diode, AC will have to diode. In steady state ID is DC and IQ is DC, because in this case it has a 0 component. Okay. Isn't it? Under steady state, if it is feeding a load, our DQ axis is fixed to synchronously reference frame. So, they are all DC. Okay. Therefore, now if you take IA, what is IA? Is root 2 by 3 into this into cos omega t plus alpha. See, IA we have will be root 2 by 3 ID cos omega t plus alpha. I think plus, is it plus or minus? Anyway, you check up IQ sin, isn't it? You go back to I naught is 0. Go back to inverse transformation of the dq to A. See, dq or DC steady state, when you go to ABC it becomes AC because of the. So, you multiply this by cos omega t. So, there will be a DC what DC component will become a fundamental frequency component, but the AC component will become what? If you again modulate a sine wave to another sine wave, what will it become? Double frequency. So, it will have cos omega t plus alpha, sin omega t plus alpha. Okay. So, from the above we can say that the current IA has a DC component and it will also have a fundamental frequency component, it will also have a second harmonic component. Now, if you write IBIC, the total of IA IBIC will be 0. Is it okay? If you right similarly. So, even after short some of the 3 currents will always be 0 instantaneously, but each of the component will have a immediately after short circuit it will have a DC component, it will have a fundamental, it has double frequency. Now, the DC component will have, where is the DC? So, that will be, if you take this where this is AC, DC component is coming because you have cos A, cos B, it will be cos and sin A, sin B. So, you have a A plus B term and A minus B term. Okay. Is it clear? Therefore, we can say that so neglect resistances, we have IA will have DC component plus fundamental frequency component plus second harmonic. Okay. Now, let us take a next case where I neglect all resistances and also transformer EMFs, neglect transformer EMF also now. Okay. Then let us see what will happen. Okay. So, Vd is 0, that is minus omega lambda q, is not it, because I have neglected p lambda d, right, and that will be, but we know lambda q is x q double dash into I q. I further do this, and this is what you apply to V q is minus V q, that is omega L A F I F, that will be equal to omega lambda d plus omega lambda d is nothing but I think there is a mistake. Okay. Therefore, this is 0, IQ is 0, right, because Vd is 0 and Id is nothing but minus Vq by xt double dash. This is another interesting thing. So, we neglect, if you find that the transformer EMF, that the flux, change of flux is not very much after a short circuit, then you have a this situation minus Vd by xt double dash. So, you will notice, and then if this is the thing, what will be Ia? Ia is simply Iq is 0 root 3 by 2 minus Vq by xt double dash into cos omega t plus alpha. Thus, in this case Ia contains only the fundamental component and no DC and no second harmonic, right. So, we are trying to analyze this, because you can always feed this into a MATLAB simulating program and get all the things, right. In fact, you should do it. I want you to try this as an assignment. Okay, and pick up what are the softwares and toolboxes available on this short circuit of synchronous machines. Please identify, I have told you already, identify the softwares and work on it, that is one of your assignments, because I would in this course your assessment depends on how much you do outside the classroom and in your own place and submit. Okay. So, that way you are free, it is an open democratic system, you are not under any constraints of examination, invigilation and question paper, etc. I given you, you have to search. So, more you do, more you will get the credit. Okay. So, your credits and grades will depend upon how many assignments that you make, right. That will be, that is very useful thing. Okay. Is it clear? Now, what you observe, that you find if you neglect resistance, you will have sinusoidal, DC, fundamental, second harmonic in the armature currents, short circuit current immediately after short circuit. But if you neglect the transformer terms also, voltages also, then you have a it will have only fundamental. Okay. Now let us take another case where I consider, I now start taking effect of dampers, right. There is a fixed resistance in the damper windings RKD, RKQ, but of course I neglect the armature resistance, right. And of course we neglect the transformer voltage. So we neglect transformer voltages. Why we are doing all the things is to give you a physical meaning and physical picture of the transient short circuit currents. Okay. In this case what will happen, of course Vd is your omega lambda q, okay. This is okay, minus this will continue to be there, lambda f is 0, Vf is 0, but Vkd will be RKD IKD plus P lambda Kd, Vkq is RKQ IKQ plus P lambda Kq. Because we are now, that means this whole exercise is to study effect of dampers. Okay. Now again you take Laplace transform, then you have the these terms, this will be lambda k, I think this will be lambda q, isn't it, is 0 we said, and this will be minus Vq by S is equal to this, not this, this is omega lambda q. What we got? See, we had this omega lambda q is 0, we are substitute for this, and these two terms, let us say equation 1, this is equation 1, agreed. All we have done is those voltage equation are taken Laplace transform, okay. And then you take lambda f is 0, again this is the third equation, then Vkd is 0, Vkq is 0, but you are considering RKD, okay. So it will have a S times LKD IKD and S times LKQ IKQ, and then the other terms will be there, okay. Okay, in this case we have the subtransient solving, we have a, we get ID as Vd by x, this is by solving. So, you have to, this you have to verify, because we have a, I mean all these terms we have to, you have ID IQ, this IQ, this ID. You get it like this, ID is Vq by xt dash plus Vq by this e to the power of minus t by tau d dash, and IQ is 0. Now in this case we define xt dash is omega LD dash. Now, one thing is, if the dampers were absent, then the situation is called a transient. If damper is present, we call it a subtransient. Okay. Effective damper is to create a subtransient, okay, to die down. So, this LD dash is LD minus 3 by 2 MEF square, and of course, IF is 0, and TD double dash is XT double dash XT LKD by RKD. Yeah. Which one? LD dash LD minus 3 by 2 MEF square. Where? LD this is LD dash, no? Let me tell you what is LD dash. I think it is okay. LD minus 3 by 2 LAF square by LFF. Sorry. LD dash is LD minus 3 by 2 LAF square or MAF square by LF. LF is the inductance of this, and we have a term TD double dash is XT double XT dash by LKD by RKD, right. Now, this is called TD double dash is called D axis subtransient short circuit time constant, and LD dash is designated D axis transient reactance. Now, when dampers are not there, LD dash is equal to LD double dash, is not it? If you do not have dampers, right, LD dash is equal to LD double dash. Okay. Now, at t equal to 0, ID is equal to VQ by XT dash plus VQ by this e to the power of minus T by TT double dash. Okay. Now, at t equal to 0, what will happen? This will become 1, it will be VQ by XT double dash, right. So, if you plot ID versus time, at the instant you will have double dash and it will die down. Okay. And what will it indicate? It will die down, and there is another term VQ by XT double dash VQ by XT double dash at t equal to infinity, what will happen? T equal to 0 is one thing, at t equal to infinity, what is ID under this expression? VQ by, right. So, it will die down from VQ by XT double dash to VQ by XT dash, right. So, it will be, okay, you can say this is agreed. Now, this will die down with a time constant, it will die down exponentially like this. So, from this value to this value it will come, and what is this? In fact, I hope you know the basic circuit concepts. If you plot, okay, if you take a slope, so this is it clear? This is how it dies down. Okay. So, we have now concluded that if you have the if you immediately short circuit, the ID will be V q by x t double dash and it will die down to V q by x t dash after some time. Okay. Now, let us take you neglect the dampers. Next case. Now, we will say let us neglect the dampers, and that means these resistors are not there, and of course, we have to say I k d equal to 0, right. Actually, it is not R k d R k q, in fact, it should be right. So, and then again we say transform voltages are 0, then what we have? We have V q is equal to minus V q that you are applying is omega lambda d is omega L d I d plus 3 by 2 M E F I F, because I k d I q are zeros. Then V q is minus V q and L d I d plus this, and V f is 0 anyway, R f I f plus P lambda f. Okay. Again you have to please solve this. I have taken the liberty of this. Okay. So, I mean, it is nothing, just like you did for the subtransient, same procedure you have to follow. Okay. And we have ID is VQ x d plus VQ x t dash minus VQ x d e to the power of minus t by T d dash, where T d dash is L f by R f into L d dash by L d, right, or L f by R f is x t dash by x t, and T d dash is called d axis transient short circuit time constant. Okay. So, when t equal to 0, I q is anyway 0, I q is 0, it is all in ID. If you neglect the transformer EMS. Okay. And ID is V q by x t dash at time t equal to 0. Okay. Then what will happen? V q by x t dash. Okay, let us see. What is t equal to infinity? What will be ID? V q by x d. So, what will happen is you have that means this whole thing is not there. Let us say you start somewhere here, and this is called this whole behavior called subtransient. Now, the actually initial point is V q by, so this will be your new time t equal to 0, okay, and you would expect this will die down, okay, from V q x t double dash, the finally what will die down to? This is V q by x d. And this is branded as transient. And of course, this is steady state. So, V q by, now when this is T d double dash, now when how this will fall down, if you plot this, okay, this will be T d dash. Is it clear? Your d axis component, which is finally DC, okay, will have this way. Okay, this is the, here it is operated through time constant T d dash. agreed, and initially it is Vq by Vq is fixed anyway, Vq by xt double dash, then dies down to Vq, because we know xt double dash is 15% let us say, right. So, it will go several times the short circuit current, then it will go like this. So, ID you have this and TD dash is this. Okay. Now, so final steady state you have IKD IKQ is 0 and IF is 0, right, and RA is 0, okay, because final steady state means even that there is IF has also reached its steady state, okay, and VD is 0, because these there will be currents induced initially. What will happen, there will be currents induced in the damper windings, then after some time damper winding current comes to 0, then there will be voltage current, extra currents induced in the field winding to oppose that change of flux where you want to maintain, okay, then IQ is 0, okay, and VD is omega lambda q is xq IQ and IQ this is 0. And VQ is minus VQ which you are applying is omega lambda d is omega LD ID XT ID. So, ID is minus VQ by XT, right. So, XT double dash is less than XT dash less than XT. So, current will reduce from subtransient to steady state, right, initially high value because same VQ. And ID will have the final expression, sorry, okay. ID will have what? So, initially no, I think this is IA is minus, that is minus root 2 by 3 xq cos omega t, okay, plus alpha, then this will be this is the steady, then there will be this value Vq by xt dash e to the power of the transient, and this will be the subtransient, okay. This will be steady, transient and subtransient. I think it is XD. XD. Now, you will notice that when time t when t equal to infinity, these terms will vanish, okay, and land up with this term only, okay. So, to we can write the current transient in terms, this is ID will be, this will be VQ by XT double dash, is not it, and here the time constant will be TD double dash, okay, and then dies down to this is subtransient, then you have a transient, that means where it will start from VQ by XT dash to VQ by XT dash, and this will be steady state. So, there will be a steady state short circuit current which is given by, which will die down now VQ by XD, okay, and the time constants are, we define this is what is TD double dash called D axis subtransient short circuit time constant, which is XT double dash XT dash by LKD by RKD. This is due to dampers, but time constant TD dash will be x d dash by x d LF by RF. Okay. Right. So, what is important for you to know is it will in the d axis so there will be a steady flux. Okay. Then whenever the short circuit there will be a tendency for variation of flux, but to maintain the flux constant the dampers will now first be effective. Okay. So, initially dampers will start carrying current, okay, and the flux will go like this, because dampers will oppose. This is a transient flux, right. Then after some time damper get tired and it will be 0 current, right. Then the flux will start penetrating like this. This is transient flux. When transient happens, then this field winding is there, is not it? This is F winding. That comes to picture because they are short circuited. It will start initially it will not have current, right. So, this will here IKD is not 0, here IF sorry IKD is 0, no IKD is not non-zero, IF is non-zero here. Okay. Then afterwards when it comes to steady state the whole flux will penetrate. When the steady state, what will happen, the transient field current or transient damper currents will be 0, right. So, this is a physical interpretation of the short circuit conditions. Maybe we will discuss a little more in the next class, but please go through this and understand, okay, by reading to the relevant literature. I also want you to read Fitzroy Kingsley's book as well as Atkins. Both of them, please read this as early as possible, preferably today. Okay, we will stop it here.